Hello everyone and welcome to lecture 3 of analysis of algorithm. In today's class we learn about classes of problems, algorithms, some important algorithm and complexity. So start the class. Complexity classes which are we already talked about in lecture 2, P, NP class and NPC class. So what is P class? P class is which type of problem those are solved in polynomial time. If we talk about the definition, problem that can solve in polynomial time by a deterministic turning machine. Deterministic mean it's solvable. Turning machine is basically compute the solution. Compute, solve. For example, we can say about binary search, it follow only one structure. Merge sort, it also follow one structure or one algorithm, or you can say it's follow only one path every time. So now let's talk about NP class, which is non-deterministic polynomial time. NP class is basically a non-deterministic problem. We can verify NP problem in polynomial time. So the verification of NP problem is the polynomial time. Verification. Verification is key point. Every P problem is also in NP problem. So if this is a set of NP problem, then there is a P problem. NP basically P is the subset of NP problem. So say about that. Example subset sum problem. Already talked about in lecture 2. Now let's go to NP complete. Definition: problem that are both in NP and as hard as any problem in NP. If any NP complete problem can be solved in P time, then P equal to NP. It's basically say that NP problem can solve in polynomial time or non-polynomial time, but it cannot verify in polynomial time. It surely can say that NP complete problem cannot verify in polynomial time, but when it can be solved in polynomial time, then we verify it polynomial time. So its solve is deterministic or non-deterministic. You can say that deterministic or non-deterministic. But verification is non-polynomial. Verification non-polynomial. Polynomial. This topic a little bit confusing, so if you have any confusion you can Google it or search anywhere to learn more about P class, NP class and NPC class. So there are some problem which are NP, and this is the subset of NP which is P class, and some problem are NP hard which is hard problem. This is hard problem, and in between this there is a NPC class. Algorithmic paradigm. So let's learn about some important algorithm. The most important, and we must know if you are a computer science student, which is divide and conquer. Idea: break problem, solve sub problem, recursively combine solution. If we talk about the smart shot, it's a Tn, then is divided plus order of n, quick shot, binary search. Let's talk about how binary search is a divide and conquer. Let's for example, we have a list of numbers. Let's 1 2 3 4 5. Let's now we have to divide this. Let's divide it two part. Finally, let's find find index number of 5. So this is the 0 index, this is 1, this is 2, this is 3, and this is 4. So 5 is basically in index 4. So how we can find? By using binary search. First we divide this 1 2 and 3, then there is 4 and 5. So we say that the require 5 is here or there. So we can see that the all value of here is lesser than 5. So we go to here and divided it two part, 4 and 5. Then we actually find 5, which is here, and then the index number is 4. So basically binary search work like this. If you want to know more, you can google it about binary search. Let's talk about greedy algorithm. Make locally optimal choice at each step with the hope of finding global optimum. If we explain this, for example, there is a graph A, B, C, and D. You A have to go D. How A can go into the D? It can be follow this path, following this path, or it can be follow this path. So let's write about the costing. Here is a costing of A to B is let's write 2, and here is 8. And let's write the costing A to C is 4, and here is a 3. So greedy algorithm basically choose the which is beneficial. For example, if we go A to B, then our costing is 2, and if we go A to C, then our costing is 4. So greedy algorithm instantly choose this one, this path, then it's go to B, then B to D. So basically the total costing of, if we follow the greedy algorithm, is 2 plus 8, then total costing is 10. So that's how the greedy algorithm work. It's can be give you the optimal solution, or it cannot be solve the problem in optimum way. If we don't follow the greedy algorithm, then if we follow this path, then our costing is 4 plus 3, which is lesser than 10. This is more I think beneficial for us because the costing is 7. Or if we and we follow greedy algorithm, so our costing is 10. This is higher. So basically greedy algorithm works like this. Now let's talk about the dynamic algorithm, dynamic programming. Break problem into overlapping subproblems, store solutions to avoid recomputation, memorization, tabulation. Uh, let's take same example which we talk about in greedy algorithm. Let's say here is a root C and D. The problem is same. We have to go A to D with minimum cost. Here the value of 2843 2843. So dynamic programming basically find the best solution. So it's have to test all the possible solution, then find the optimal one. Then it tests the first one, which is 2 plus 8, which is 10. Then it tests this one, which is 4 plus 3, which is 7. Then it's compare between this, then best, which is best, then the minimum cost is here. So dynamic programming follow this path, A to C, then C to B. So that's how the dynamic programming works. I think you understand now. Oh, one important things I need to tell you that in divided and conquer rules, when we divide this part and this part, these two parts are not dependent each other. They are not dependent each other. And here and there is also they are not dependent each other. But when we use dynamic programming, if we divide something, then they are dependent each other. They are dependent each other. So this is important things you need to remember. Now let's talk about complexity of algorithm. Time complexity, very important. How runtime grow with input size n. Notation, it can be big O, omega and theta. Big O is worst case. When we run a algorithm, we always consider big O, the worst case scenario. And this is the best case, and this is the average tight bound. So this is some algorithm and their time complexity is here. In binary search is VGO of log n, then bubble sort VGO of any square, Marsh sort, then quick short. In worst case, this is the average case, and recursive solution, Fibonacci. This is how they work. This is take less time. This is the more optimal solution. Binary search. If we searching something, in short, here is this is the optimal one for searching, this one and this for shorting. Now talk about space complexity. In today world, this is not so important because space means memory, and memories are cheaper day by day. So memory complexity is, or space complexity is not important as like time complexity. But you need to remember that how is and what is space complexity. How much memory is used as input grows. So it's basically same like complexity of time. Its space complexity is calculate the total storage a algorithm can take or use. If we summarize all the thing we study in lecture 3, and there is the summary table. In p class solvable in polynomial time, and there are the example. Then np class verifiable in polynomial time, yes. NP complete hardest problem in NP, yes. Divide and conquer, recursive break and combine, it's break and combine, yes. Greedy, local optimal, global, yes. Is greedy algorithm choose the best one at present time. Then dynamic programming overlapping sub problem, yes. Overlapping, then check it the best one. Time complexity, growth of execution time, space complexity, memory uses. So that's all for today. Thank you for stay with us, and if you have some queries you can write in the comment box.